On July 19, 1978, in the restoration workshops of Notre Dame de Paris, a structural engineer named Jacques Moreau examined a gargoyle removed for conservation. Rain drummed against workshop windows. The air smelled of wet stone and metal tools. He was documenting internal erosion patterns for the restoration committee. Routine work assessing which gargoyles needed replacement versus repair. He cut a cross-section through the damaged throat of the gargoyle to examine water channel deterioration. The interior was not a simple hollow tube. Inside the stone, a complex system of channels. Not one passage, but three, spiraling around a central void. The channels measured precisely: 3.2 centimeters, 6.4 centimeters, 12.8 centimeters in diameter. Geometric progression. Each channel carved with spiral grooves along its interior surface, the grooves spaced at regular intervals. The outer channel contained copper residue, traces of metal that had lined the passage long since corroded away. Moreau measured the angles of the spiral grooves: 137.5 degrees. The golden angle, the same mathematical constant encoded in Gothic arches, in rose window geometry, in spire proportions. He examined other gargoyles awaiting repair. Every one contained similar internal complexity: multiple channels, spiral grooves, copper traces, precise geometric ratios. These were not simple drainage spouts. They were engineered devices. His report to the Restoration Committee, dated August 1978, noted, "Gargoyle internal structures exhibit sophistication inconsistent with purely functional drainage requirements. The complexity suggests additional purpose beyond water removal." The committee's response: interesting observation. However, restoration priorities focus on external form and structural stability. Internal channel geometry not relevant to current project. Moreau's detailed measurements and photographs were filed with the restoration archives. The report was not included in published restoration documentation. History remembers progress, but forgets what it replaced. By the autumn of 1247, according to construction records from Notre Dame, gargoyle installation had become a specialized craft. Fog rolled through Paris as master carvers received specifications for gargoyles à canaux multiples, gargoyles with multiple channels. The specifications, discovered in 1993 in the cathedral building accounts, listed precise requirements: 3 channels spiraling around central void, outer channel to be lined with copper, inner surfaces carved with helical grooves at angle of divine proportion, water flow to be tested before installation. Divine proportion, the golden ratio, 1.618, corresponding to the 137.5-degree golden angle. The specifications included payment rates: 45 livres per gargoyle, extraordinary compensation for what official histories describe as decorative water spouts. For a comparison, a master mason earned 12 livres per month. A single gargoyle cost nearly 4 months of master mason wages. Someone valued these objects far beyond their apparent function. On a cold morning in February 1289, a mason's letter described gargoyle testing procedures. Frost coated Seine River banks as water was poured through newly carved gargoyles before installation. The letter, held at the Bibliothèque Nationale, stated, "We test the gargoyles by pouring water through them. The water must emerge in 3 separate streams that spiral together. We measure the sound produced. It must ring at the correct frequency." Only gargoyles that pass both tests are installed. The sound produced. The water must ring at the correct frequency. Water flowing through the spiral channels created vibration, generating sound. The multiple channels, the spiral grooves, the copper lining, all contributed to producing specific acoustic effects when water passed through. The gargoyles were musical instruments, or rather, they were acoustic transducers, converting water flow into sound at precise frequencies. Shadows lengthened across 14th century Chartres as sculptors carved gargoyles to exacting standards. A guild record from 1327 specified, the throat channels must spiral at the golden angle. The copper lining must be 2 millimeters thick. The flow must produce tone matching the cathedral bells. Tone matching the cathedral bells. The records listed target frequencies: 64 Hz, 128 Hz, 256 Hz. The doubling pattern found in bell tones, in spire acoustics, in copper network frequencies. During rain, hundreds of gargoyles would activate simultaneously, each producing its designated frequency as water flowed through, creating a chorus of tones across the building, layering with bell sounds and spire resonances. The entire cathedral became a hydraulic orchestra. Heat shimmered above Vienna in the summer of 1893, when an engineer examining gargoyle designs noticed something unexpected. He was comparing medieval gargoyles to modern drain pipes for a paper on historical construction methods. The medieval designs were far more complex than necessary for simple drainage. His analysis, published in an obscure Austrian engineering journal, calculated the spiral channel design creates turbulent flow that increases water velocity by approximately 40% compared to straight channels of equal diameter. The multiple channel arrangement distributes pressure evenly, preventing stone fracture. The system is hydraulically superior to modern equivalents. He noted, the medieval engineers understood fluid dynamics principles not formally described until Bernoulli's work in 1738, 4 centuries after these gargoyles were carved. The paper received minimal attention. The journal ceased publication in 1897. Coal smoke drifted through London in 1904 when a maintenance crew discovered something while cleaning gargoyles at Westminster Abbey. Inside one gargoyle's central void, a small bronze chamber, approximately 8 centimeters in diameter, containing what appeared to be a resonating cavity tuned to specific frequencies. The foreman's report, held at the Abbey archives, described found metal chamber inside gargoyle throat. Chamber contains ridges creating interference pattern. When water flows past, chamber vibrates at steady tone. Purpose unknown. The chamber was removed for study. It disappeared within weeks. The official explanation: item misplaced during cataloging. In pencil on the margin of the report, not misplaced, taken deliberately. By 1911, evidence had accumulated that gargoyles served purposes beyond drainage. In Prague, during cathedral repairs, workers discovered that gargoyles connected not only to roof gutters, but to internal channels within the cathedral walls. Channels that led to cisterns, to copper networks, to chambers beneath the foundation. The gargoyles weren't just removing water from the roof. They were distributing it throughout the structure, directing flow to specific locations for specific purposes. An engineer's memo from 1912, discovered in Czech archives, noted, water flow through gargoyle system maintains humidity in wall cavities at approximately 40 to 45%. This prevents stone cracking while avoiding mold growth. The system regulates moisture with precision. Precision moisture control. In structures built centuries before, humidity was understood scientifically. Rain fell in slow drops on a morning in 1923, when a physicist in Munich measured sounds produced by gargoyles during storms. He used early recording equipment to capture the acoustic output of multiple gargoyles on a single cathedral. His findings preserved in laboratory notebooks. Each gargoyle produces distinct frequency when water flows. Frequencies form harmonic series 64, 96, 128, 192, 256 Hz. During heavy rain, combined output creates standing wave patterns measurable throughout cathedral interior. The physicist noted, "The effect is not incidental. The gargoyles are positioned at specific points where their acoustic output reinforces resonant frequencies already present in the structure." He submitted his findings to a scientific conference. The paper was rejected. The rejection stated, measurements likely affected by equipment limitations. Acoustic claims unverifiable. On the rejection letter, someone wrote, or too verifiable. Frost coated metal in January 1934, when restorers at Cologne Cathedral discovered something inside gargoyle channels. The channels contained not just copper residue, but traces of other metals. Silver, traces of gold, precise alloys designed for specific properties. The metallurgical analysis conducted at the University of Cologne showed metal composition matches that used in bell founding. Bronze with silver additions to enhance acoustic resonance and prevent corrosion. The metals were applied as thin lining, not structural element. The analysis concluded, the expense of precious metal lining suggests function beyond structural need. The report was filed with cathedral archives. It was not included in restoration publications. Meanwhile, hydraulic analysis of gargoyle systems revealed unexpected sophistication. In Paris, during 1947 restoration work, engineers calculated flow rates and pressure dynamics of Notre Dame's gargoyle network. Their findings: the system could handle rainfall rates up to 200 millimeters per hour without overflow, far exceeding typical Paris rainfall maximums. The gargoyles were over-engineered for their drainage function by a factor of 3. But they were perfectly sized for other purposes. Generating specific acoustic frequencies required minimum flow rates and pressures that matched normal rainfall patterns exactly. The drainage was incidental. The acoustics were intentional. Dust moved through lamplight in 1956, when an art historian examining gargoyle symbolism noticed patterns in their positioning. Gargoyles weren't randomly placed around cathedral perimeters. They occupied specific locations corresponding to acoustic nodes, points where sound waves from bells and spires would intersect and interfere. Her analysis, submitted to an architectural history journal, proposed gargoyle placement follows mathematical pattern relating to sound propagation. They mark positions of acoustic significance. The journal rejected the paper. The rejection stated, gargoyle placement determined by structural drainage needs. Acoustic considerations unlikely. In the margin of her manuscript, yet the pattern holds across every Gothic cathedral examined. By 1973, acoustic engineers studying Gothic architecture began to understand what the gargoyles contributed to overall cathedral sound. The multiple spiral channels didn't just carry water. They acted as Helmholtz resonators, acoustic devices that amplify specific frequencies. When water flowed through the channels, turbulence created sound. The spiral grooves modulated that sound into discrete frequencies. The copper lining enhanced acoustic transmission. The bronze chambers added resonance. During rain, the entire building sang. Bells, spires, gargoyles, copper networks, resonant chambers, all producing overlapping frequencies that filled the interior and extended hundreds of meters beyond the walls. The gargoyles were the final acoustic element, activated by weather itself. Heat pressed against windows in 1989, when a researcher compiling data on Gothic hydraulic systems discovered coordination between gargoyles, cisterns, and copper networks. Water flowing through gargoyles didn't just drain. It was collected in cisterns positioned at nodes within the building. From those cisterns, channels led throughout the structure, distributing moisture to wall cavities, to copper networks, to chambers that seemed designed for water interaction. One channel led from a cistern directly to a chamber containing a large magnetic cross. The channel was lined with copper. When water flowed through it, the copper would be surrounded by flowing water, an arrangement that would affect magnetic field stability and conductivity. The water system wasn't separate from the electromagnetic system. It was integrated. Water flow affecting copper networks, affecting magnetic crosses, affecting acoustic resonance. Rain fell through centuries, activating the system repeatedly, maintaining it through cycles of storm and drought. Modern analysis of surviving gargoyles reveals extraordinary precision. Laser scanning of internal channels shows spiral groove spacing varies by less than 0.5 millimeters across an entire gargoyle. Channel diameter ratios hold to within 2% tolerance. Golden angle spirals maintain 137.5 degrees within measurement error. This precision required not just skilled carving, but detailed blueprints, mathematical calculations, quality testing, industrial-level engineering applied to what historical narratives describe as decorative architectural elements. In 2003, researchers tested a replica gargoyle carved to medieval specifications. They lined it with copper, carved the spiral grooves at the golden angle, created the three-channel system. When water flowed through during testing, the gargoyle produced clear tones at 128 Hz and 256 Hz. The tones persisted for several seconds after water flow stopped, the channels and chambers resonating like organ pipes. The test confirmed medieval gargoyles were precision acoustic instruments that happened to also drain water. If history is written by survivors, who erased the rest? Today, gargoyles perch on Gothic cathedrals across Europe. Thousands of them, carved between 1150 and 1350, containing spiral channels, copper traces, bronze chambers positioned at acoustic nodes. Tourists photograph them. Architecture students sketch them. Maintenance workers occasionally replace them with modern drainage pipes. Almost none know the gargoyles contain multiple spiral channels at the golden angle. Almost none know they were lined with precious metal alloys designed for acoustic resonance. Almost none know they were tested before installation to verify they produced correct frequencies. Almost none know they were positioned at locations corresponding to acoustic nodes, connected to cisterns and internal distribution channels, integrated with copper networks and magnetic crosses. The evidence survives. The construction specifications listing three-channel spirals at divine proportion, the extraordinary payment rates, the testing procedures requiring correct acoustic frequency. the metallurgical analysis showing precious metal linings, the guild records demanding tone-matching cathedral bells, the 1912 engineering memo noting precision moisture control, the 1923 acoustic measurements showing harmonic series output. What survives less clearly is comprehensive understanding. The gargoyles drained water. This is documented. But they also generated sound, regulated humidity, distributed water throughout internal channels, interacted with copper networks, maintained magnetic field stability, contributed to the cathedral's overall acoustic and electromagnetic environment. They were multi-function hydraulic acoustic electromagnetic transducers disguised as decorative water spouts. The medieval engineers who designed them understood fluid dynamics, acoustics, electromagnetics, materials science, not through modern theoretical frameworks, but through empirical observation and systematic engineering developed over generations. That knowledge was encoded in stone, preserved in functional form for 7 centuries, described in fragmentary records that official histories overlooked as they focused on architectural grandeur and spiritual symbolism. The gargoyles still function. During rain, water flows through their channels, creates turbulence in their spiral grooves, resonates in their chambers. The acoustics are still there, measurable, real, whether anyone remembers to listen or not. Standing as they have for centuries, their copper linings mostly corroded, but their channel geometry is intact. Their golden angle spirals still guiding water in calculated patterns. Their multi-function purposes operating in plain sight, visible to anyone who looks carefully at what historical narratives dismissed as mere decoration. Yes, dear listeners, this video ends here. I'm taking your suggestions into consideration. You can write anything you remember in the comments. Thank you for listening.